Semantic alloy describes what happens when concepts from different domains stop behaving as separate units and begin functioning as one indivisible cognitive mechanism. At that point, the result is not comparison and not simple synthesis. It is a new semantic material. Once alloyed, the original parts can no longer be separated without damaging the function of the whole. What emerges is a fused structure with properties that did not exist in any source domain alone. This is why a semantic alloy should not be understood as a metaphor. It does not mean that two ideas are merely related. It means they have combined into a single operational form. When this happens, thought no longer proceeds by switching between domains. It proceeds through integration. The system is no longer translating from one field into another. It is thinking through a fused material that already contains multiple fields at once. This produces several effects. It allows non-linear reasoning because the fused structure can move across domains without having to rebuild connection each time. It allows cross-disciplinary coherence because the alloy carries its own internal stability rather than depending on constant explanation between source fields. And it allows forms of structural resilience that would not exist if the concepts remained separate. A semantic alloy, therefore, is not just a hybrid. It is a new cognitive material with its own density, strength, and behavior. If semantic alloy explains fusion, semantic physics explains motion. Semantic physics begins from a different claim. Meaning does not behave like a static symbol. It behaves more like matter moving inside a field. Under this model, meaning has behaviors that can be described structurally. It can accumulate, it can attract, it can bend surrounding interpretation, it can overload local systems, it can drift, compress, or collapse. This is why semantic physics treats meaning not as a passive sign, but as something with field behavior. A dense meaning does not simply sit in place. It pulls other meanings toward itself. It changes what can move near it. It alters the path interpretation takes through the field. A low-density region behaves differently. Meaning diffuses more easily there. Structures loosen. Interpretation does not bend as sharply. This makes it possible to describe why some ideas reorganize entire environments, while others remain weak, scattered, or unable to hold shape. Semantic physics can therefore describe why certain meanings become centers of attraction, why high-density cognitive regions distort nearby structures, and why singularities form when complexity exceeds what a field can contain. In this framework, meaning behaves like matter, interpretation behaves like motion, and the field reorganizes according to internal pressure rather than personal preference alone. Taken together, semantic alloy and semantic physics describe two different but connected layers of semantic architecture. Semantic alloy explains what a concept becomes once fusion has stabilized. Semantic physics explains how that fused or unfused concept behaves once it is active inside a field. One describes material formation, the other describes field dynamics. One answers, what has this semantic structure become? The other answers, how does it move, attract, distort, or collapse? Together, they make it possible to think about cognition in a way that can handle recursive interpretation, multi-domain compression, and high-density semantic operations without immediately falling back into metaphor or loose analogy. This is why the system is not meant as symbolic ornament. It is meant as functional architecture. Semantic alloy names the formation of fused semantic material. Semantic physics names the laws of movement, pressure, attraction, and distortion that govern meaning once it is active. Both constructs originate within the meta-writing ecology. They are not borrowed from prior academic terminology as ready-made frameworks. They appear here as internally generated constructs for describing how meaning fuses, how it gains density, and how it behaves once it enters a live cognitive field.